We are WPI's high-powered rocketry club. With over 100 student members, we devote ourselves to the research, development, and launch of a high-powered rocket and payload system. At WPI, we've realized a need to extend ourselves beyond the classroom and embody our motto of theory and practice. We do this by engaging in holistic, challenging engineering experiences as competitors in high-level rocketry competitions. We also include in our mission member education and collaboration across 7 technical and 3 administrative subteams.
Since the beginning of the semester, our team reached a number of significant milestones and overcame various challenges while balancing our full compliance with WPI's COVID-19 preventative measures. One of the greatest highlights has been our acceptance to compete in the Intercollegiate Rocket Engineering Competition hosted at Spaceport America in June of 2022. For this competition, our payload team developed a mission of designing and building a payload capable of autonomously locating our launch vehicle upon landing for recovery. The team explored various design concepts, weighing their pros and cons, and created prototypes of a quadcopter and 2 types of fixed-winged aircrafts, before ultimately selecting a folding quadcopter design. In the rocket division, the coupling subteam worked on motor retention and explored a new, innovative design for connecting sections of the airframe by coupling them together. Despite the design challenges of having these connection points withstand the significant aerodynamic forces faced during flight and recovery, as well as the manufacturing challenges in creating ease with assembling the couplings, our coupling subteam was ultimately able to successfully build and test a functional prototype. In the aerostructure subteam, design settled on a fiberglass airframe, and members learned how to do a fiberglass layup for the fins and conduct composite analysis using ANSYS. The airbrake subteam reviewed multiple new design choices, but ultimately settled on a new iteration of our last year's airbrake design. Thanks to materials and components funded by Tinkerbox, we were able to build a prototype and collect useful performance results for review. The recovery subteam has taken on 2 challenges new to the team: single-end deployment and CO2 ejection. The team performed 5 successful ejection tests using last year's rocket at our sponsoring Test Devices facility with the support of their engineers. 3 tests, of which were of the new CO2 ejection system funded by Tinkerbox, and 2 of the black powder ejection system used in previous years. Furthermore, in early December, we conducted an all-team internal design review, where members of each subteam in each division presented their ideas, answered questions, and engaged in constructive criticism with our whole team.
But our constructive criticism extended beyond just ourselves. Thanks to Scott Harris, a mentor and advisor provided by the Tinkerbox program, we got insight and drew upon his professional experiences to help us solve manufacturing challenges and plan project deliverables. With the funding and resources provided by the Tinkerbox program at WPI, we were able to realize our mission to a greater extent than we would have otherwise. Thank you, Tinkerbox.